Hi everyone, welcome to my channel Do and Learn. Let us learn. In this session, we are discussing the chapter Motion in a Straight Line based on NCERT Syllabus, Grade 11 Physics. Part 1. This is the first part of this lesson. In this part, the contents are motion, position, path length and displacement, average velocity and average speed, instantaneous velocity and speed, acceleration. So let us start with the first one. What is motion? Motion is change in position of an object with time. Change in position of an object with time. So this lesson explaining what is called rectilinear motion. Rectilinear motion means the study of motion of object along a straight line. If the object is moving along a straight line, then we can see this one-dimensional motion. It is also called a rectilinear motion, one dimension. So there are, as you know, that there are one dimension, two dimension, three dimensional things. You might have heard the 2D, 3D many places in movies and all. So any type of motion. A motion means there are different types of motion. Motion means object should change its position with respect to time. Object should change the position with respect to time. There are different types of motion. As you can see in the picture, there are some examples. So let us go to the next topic. Position, path length and displacement. What is position? The definition is, position is the place where someone or something is located or has been put. Look at this picture. You can see a football is placed on a football court exactly on a line. So we can say that the football is placed on a line in a court. So we have to find the position. So we need to find some points to refer it. Example, like as I told you, the football is placed on a line. So there must be a line, and the line is inside a football court. So to explain the position of an object, we need to have three dimension or axis. It is called a coordinate system. In this coordinate system, mainly there are three types of axes: X, Y and Z. Look at this drawing. It could be X along X axis, Y along Y and Z. You can see there are three axes: X, Y and Z. So the point of intersection of these three axes, the center point, you can see this is the point of intersection, or we can see this origin, starting point. This point is called origin. This point is called origin. So this is a point of intersection of three axes. So if to measure the time, because if the object is in motion, we need to know the value of time. To measure the time, we position a clock in the system. In the previously shown the XYZ system, if you put a clock, then you can measure the time. If you put the clock in the system, so we can say it constitutes a frame of reference. X, Y, Z axis with the time is called a coordinate system along with the clock. That means, as I told you, X, Y, Z axis with the time is called frame of reference. So here in this lesson we are discussing only one dimensional motion. So we will consider X or Y or Z, only one axis. So let us go to the next topic. What is path length? Path length is called distance. Path length is same. Distance. Path length means it is a distance between 2 points along a straight line. Suppose one man is moving from one place to another. Suppose one place, so one location to another location. So the distance traveled by the person is called its or his path length. Okay. So look at this picture. The down, you can see object. Suppose person is standing at the point O. okay, this point, and is moving to the point Q, we can say the path length is equal to the distance between the point O to Q. Okay, how much it is written already there? 240 meter. This is a distance or the path length. Second, he is continuing his travel to the point P. So the distance is 360. Now reached 400 meter. Now assume that he is going back to the initial point O. So what is the total path length? Total distance covered. Total distance covered 400 plus 400. Okay. So this is a scalar quantity. Scalar quantity means the quantity that has only magnitude. The quantity that has only magnitude. Okay, there is another quantity called a vector. Vector means the quantity has magnitude and direction. We will discuss about vectors and scalars in the coming lessons because we are only considering one dimensional here. Let us go to the next topic, displacement. Displacement is the shortest distance between the final position and the initial position of the motion of an object. I'll explain you with an example. Consider a rectangular court. Okay, rectangular court. Four corners, I'm just giving the name A, B, C and D. Okay, and the distance A to B is, suppose the distance between A to B is 4 meter, B to C is 3 meter, so C to D is also 4 meter and D to A 3 meter. So let us discuss what is displacement and what is the difference between displacement and distance. Let us take distance as S and displacement as D. Okay, this is for distance, this is for displacement. Let us consider one person is moving from the point A. Is moving from the point A. Okay. Suppose object is moving from, the person is moving from A to B along the path AB. Okay, so tell me from A to B, what is the distance traveled by the person? Distance traveled by the person. So it is clear, it is given already there. It is 4 meter. So what is the shortest displacement? We have to find out what is displacement. What is the shortest distance between the point A and B? Because it is straight line, so the shortest distance is equal to the straight line distance, right? So we can say that displacement is also equal to 4 meter. Okay. Next, consider again the person is continuing his motion and he is moving from A to B and then B to C. At this moment, he has reached the point C, traveling from A to C. Let us calculate the distance and displacement. Distance is how much? The previously I showed you distance is equal to total distance covered, path length. So we can say that is equal to 4 plus 3, how much? 7 meter. So what is the displacement from A to C? What is the shortest distance? Because we know that there are 2 points, that is A and C. These are the initial and final position. How will you find the shortest distance between A to B? If you travel from here to here in this way, that is not the shortest distance. If you travel this way, also that is not a shortest distance. But if you can travel like this, look at this. If you can travel like this, you can reach C faster than ABC path. So A to C, you can draw a diagonal. This will be the shortest distance between A and c. So let us calculate the distance. You can use the Pythagoras theorem. You can calculate d is equal to square root of ab square plus bc square, right? So we can write 4 square plus 3 square. 4 square plus 3 square, with regard is our answer. That is 16 plus 9. 16 plus 9 square root of 25. Square root of 25. What is the value of square root of 25? 5 meter. Okay. So we have got distance is equal to 7 meter. Displacement is equal to 5 meter. It is clear that displacement is less than distance. Displacement is less than distance. Again, he is continuing. He is traveling from C to D now. Now let's consider another example. C to D. C to D. What is the total distance traveled? You can add 4 plus 3 plus 4. 4 plus 3, 7. 7 plus 4, 11 meter. What is the displacement? Shortest distance between A to C. A to D. A to D shortest is clear. That is 3 meter. Okay, look at the difference. Now, is coming back to the initial position. Now the distance between A to A along the rectangular path equal to 4 plus 3 plus 4 plus 3. How much? 4 plus 3, 7. 4 plus 3, 7. 7 plus 7, 14 centimeter. But what is displacement? Displacement, because shortest distance between initial and final position, there is no distance. So we can say that is 0. So from this example, it is clear that displacement can have 0 while distance has some value. It is clear that displacement can have 0 with some values in distance. Okay, so we can say the magnitude of displacement is either equal to or less than the distance. So what is the difference? From this example, it is clear the difference between distance and displacement. We can say that the distance is a total length of path through which a body moves, but displacement is the shortest distance from initial and final. The difference, the magnitude of displacement is either equal to or less than the distance. Then the distance is the length of path traveled by the body, so it will be always positive. But the displacement is shortest length in direction. The displacement has direction, so it can have negative, positive, or can have 0. The displacement can be 0 even if the distance is not 0. These are the main difference between distance and displacement. Look at this another picture. The two lines A to B. So if object is traveling from A to B in this way, it has to cover, suppose it is covering 30 meter. So distance is equal to 30 meter. Displacement will be the shortest. A to B, this is the shortest distance. It will be always less than 30 in this case. Can have 20. This is called displacement. Let us see what is uniform motion. What is uniform motion? Simple. Uniform motion means if an object moving along the straight line covers equal distances in equal interval of time. Equal distance in equal interval of time. Consider an example. At 10 seconds, object is covering at 0 seconds, starting 0, object is at 0 position. At 10 seconds, object is at 20 meter. At 20 seconds, object is at 40 meter. At 30 seconds, object is at 60 meter. At 40 seconds, object is at 80 meter. It is clear that what is the time interval here? The time interval is here is 20 minus 10 or 30 minus 20 or 40 minus 30. Time interval is 10 seconds. For every 10 seconds, object traveling 20 meter. This type of motion is known as uniform motion. So the object is moving along straight line, covers equal distances in equal intervals of time. Equal distances, equal intervals of time. We can draw a graph of it like this. Second graph, this is a graph. In the graph, so the previous example I can show with this graph, 10 second, 20, 30, 40. So 10 second, object is covering a distance of 20 meter, right? At 20, 40, at 30, 60, at 40, 80. So if you draw a graph like this, if you mark the points, you will get a line like this, straight line. But in the first one shows the object is not in motion. It means at 0 second, object position is at 40 meter. At 10 second, object is 40 meter. At 20 second, object is at 40 meter. At 60 second is also the object is at 40 meter. It means object is always at 40 meter distance from the origin, reference point. So the line will be, the graph will be, the curve will be parallel to the x-axis. Look at this, parallel to the x-axis. Okay, this is the graph for stationary object. Second is the graph for uniform motion. Suppose the object is moving, another case, let us consider another case. Object is moving along the straight line, covers unequal distance in a time interval, unequal distance. Example, suppose the car, suppose you are starting your car or your bike or bicycle. Initially the bike or car will go slowly, then it will increase speed. After some time you can have the regular, a constant speed, and it is always varying. You have to put the gear and accelerate, brake. So we can't go with the uniform speed, right? So it is always changing. If you explain that type of motion in a graph, it will be like this. Look at this. At 0 second, object is at rest. At 2 second, object is at rest only, slowly started. At 4 second, it is covering some small distance. Look at this. From here we have 0 to 50, maybe it is 5 meter. At 6 second, object is covering some distance around 20. At 8, increasing the distance. At 10, we can say at 10 straight line, more than 50, it is always varying. But from this point to this point, we can say straight line can have uniform or can have uniform motion. Then again it is changing. I will explain more about this in the coming session. So let's go to the next topic, is what is average velocity and average speed. What is average velocity and average speed? Velocity and speed. You might have heard this word velocity and speed in the previous classes. Let us revise. Average velocity is defined as a change in position or displacement divided by the time intervals in which the displacement occur. Suppose object is moving from one place to another place. There are different time interval we have. Time t1 to tn, different time interval, different locations. So if we consider a particular point, if we can find the displacement happened in this area at this time is called its average velocity. So look at this mathematical expression. So we are considering two positions. One position is considered, we can denote as x1, another position x2, one time interval t1 and t2. So we will find out the difference between difference between the 2 points, delta x. Delta we use always to find some differences, and delta t. This will give the velocity. The bar indicates average velocity. Okay, so average velocity, let us do how to calculate the average velocity. Look at the graph. Look at the graph. Look at the graph. I will explain you how to calculate the average velocity. So I already showed you this mathematical expression x2 minus x1 t2 minus t1. Let us consider object is moving. This is a graphical representation of the object motion, position and time graph. Look at this x. X means it is denoted position and time graph. In this graph, look at this. At the origin point, object is slowly started and gaining speed, covering some distance and going away. So the time is also increasing. Let us find out the average velocity between the point, 2 points. This is a whole motion. It is starting from this point until this point. But we are considering, as I told you, we are considering in average velocity, we will only consider 2 points, right? It is defined as the change in position or displacement divided by the time interval in a particular time interval. So we are considering time interval between 5 seconds and 7 seconds. 5 seconds and 7 seconds. So 7 seconds. So we can say that time t1, first time 1 is 5 seconds, time 2 is 7 seconds. We are considering the displacement between 5 and 7 seconds. Okay, so let us find the distance traveled at time t1, 5 seconds. This p1 shows the distance that is equal to 10 meter. So that is the first position. We can use the letter x1 to denote. X1 is the first position, that is 10 meter. Then go to the second position, that is point p2. P2, go to the y-axis. Here it is given 27.4. So x2 is equal to 27.4 meter. Now we can calculate the velocity, average velocity equal to, the formula is already there, x2 minus x1 divided by t2 minus t1. x2 how much? 27.4 minus 10 divided by t2 minus t1, 7 minus 5. You can do this calculation. 27.4 minus 10 is equal to 17.4 divided by 7 minus 5, 2. That is equal to how much? You can calculate, that is equal to 8.7. 8.7. What is the unit of velocity? What is the unit of velocity? Because the formula, we have the unit of distance, that is meter. We have the unit of time, that is seconds. So meter divided by seconds. We can say meter per seconds. This will be the unit of velocity. 8.7 meter per second. Okay. This is the way we calculate the average velocity. Let us continue the average velocity and average speed, the graphical representation. The first graph represents the position time graph for an object moving with the positive velocity. So the second graph, B, moving with the negative velocity, C, at rest. Okay. Now let us move to what is average speed. What is average speed? Speed means average speed defined as the total path length traveled divided by the total time interval during which the motion has taken place. In this case, we will consider the total path length traveled by the total time interval. Suppose if we are traveling from one place to another, A to B, we will consider the total distance if it is 100 meter and the total time that will be 100 meter, 20 minutes. So 100 meter, 20 minutes. We will consider total distance and total time. So you can calculate. We have the formula to calculate the speed. We can use the formula. Average speed is equal to total path length. Total path length. Speed is equal to total path length, that is total distance, divided by total time. Total time. Distance divided by time. So the unit will be same as velocity meter per second. Let us continue. Another topic, instantaneous velocity and speed. Instantaneous velocity and speed. What is instantaneous velocity? Instantaneous velocity, symbol velocity v at an instant t. At an instant t. So the velocity at an instant is defined as the limit of the average velocity as the time interval dt becomes infinitesimally small. It means we will consider the speed or the velocity of an object at a particular instant, very small interval. With the mathematical expression, we can write v is equal to limit delta t tends to 0 delta x by delta t. It means, so we are limiting, the time is we are limiting to 0. It means we are reducing the time interval near to 0 at very less interval of time. So limiting the time to 0. So when the speed of a body keeps on changing, so if you travel on a car or if you drive a car or a bike, the speed is always changing. You may not go there in a particular constant speed. Speed may increase, it may reduce. You will apply accelerator, you will apply the brake, you will change the gears. So the speed is always varying. So when the speed of a body keeps on changing, its speed at any instant is measured by finding the ratio of the distance traveled in very short time. That's what delta x is shown. The travel, very short time, the distance traveled in very short time to the time interval. So this speed is called instantaneous speed, or instantaneous, you can say instantaneous velocity. So we will consider a very small time interval and we will measure the distance traveled in that very small time interval divided by that small time interval, delta x delta t, and we will mathematically we had to use the limits. We are limiting the time, the small time interval near to 0. This is what I mean, limiting the delta t. The delta t means the time interval limiting to 0, delta x by delta t. I'll explain with an example. Left side you can see a picture. This is a speedometer, right? Speedometer. The speedometer shows, the speedometer of a vehicle measures the instantaneous speed. The speedometer of a vehicle measures the instantaneous speed because it will always shows the time speed at a particular instant, speed or velocity at a particular instant. Okay, so it is changing 140, 120, 60, 80, it changes. So at a particular small time interval, the speed we can calculate the small the speed of an object. Let us go to the next topic, acceleration. Acceleration means the average acceleration is over a time interval is defined as the change of velocity divided by the time. Change in velocity divided by the time. So mathematical expression, v2 minus v1 divided by t2 minus t1, that is equal to delta v divided by delta t. So we will consider the velocity difference, change in velocity. Suppose the velocity of an object is v1 at particular point v1, then it is changing to v2 during the time interval t1 t2. So we can calculate velocity is equal to difference between the velocities and change in time. Okay, simple, change in velocity divided by time taken. That is called acceleration. So what is instantaneous? Very simple, same as the velocity you can explain. Instantaneous acceleration means the acceleration at an instant. Acceleration at an instant. So we will consider acceleration of an object in a small time interval. We will limit the time to delta t to 0. Look at this expression. We will limit delta t tends to 0. Means limiting the time to near to 0, and we'll calculate change in velocity divided by change in time. So in calculus method we can use dv divided by dt. We'll study this differentiation in the coming lessons. Very simple, we are limiting the time to near to 0. We will consider the acceleration of an object at an instant. That is called instantaneous acceleration. Let us see how to represent the acceleration in graph. The first graph shows the positive acceleration. The first graph is a positive acceleration. The position time graph of motion with positive acceleration. Second graph is negative acceleration, and third is zero acceleration. So zero acceleration, you can see the position time graph, distance increasing while increasing the time, and if there is a constant velocity means the acceleration will be zero. There is no change in the velocity. The velocity v1 and v2 are equal. If v1, suppose the v1 is equal to v2, so v2 minus v1 is equal to 0. In that case, the acceleration will be 0. There is no acceleration. So first positive acceleration, negative acceleration, that means retardation. So suppose you are applying a brake, so negative, the speed reduces, that's negative acceleration. Zero acceleration, if an object moving with the constant speed or constant velocity, the acceleration will be 0. And the graphical representation continuing, an object is moving in a positive direction with a positive acceleration. Positive direction with the positive acceleration, you can see the velocity increasing from v0 to v. This is velocity time graph. We can say velocity time graph. So velocity increasing from v0 to v at a particular time interval t. So velocity increases, so positive direction with the positive acceleration. So second, an object is moving in positive direction with a negative acceleration. If you apply the brake, still the car moves forward and then only stops. So car is moving in the positive direction only, but the velocity reduces. Velocity reduces from v0 to v. Final velocity, initial velocity, final velocity. Look at this, v0 to v, the velocity reduces. So this is positive direction but negative acceleration. And this graph explains an object is moving in a negative direction with a negative acceleration. Negative direction with a negative acceleration. So v0 and minus v. Minus v0 minus v, it is a graph minus y axis. So it is clear the velocity is reducing. And another graph, an object is moving in positive direction till time t1, then turns back with the same negative acceleration. So from here to here, object is in the positive direction until time t1. From t1 to t2, it is turns back with the negative acceleration. So that's all the topic in the first part. Let us discuss what we have learned in exam point of view. We have discussed what is called motion. Motion is a change in position of an object with time. Position is a place where someone or something is located or has been put. And we have discussed what is path length. It is a distance between 2 points along a straight line. And displacement, it is a shortest distance between initial and final position. And we have discussed what is average velocity. It is a change in position or displacement divided by the time interval. And average speed, it is a total path length divided by total time. Total path length divided by total time. And instantaneous velocity, the velocity of an object at an instant, a particular small interval of time. We will limit the time to 0. An average acceleration is defined as the change of velocity divided by the time interval. In the next video, part 2, I'll explain kinematics equations for uniformly accelerated motion, how to derive kinematics equations. And part 3, I'll explain what is relative velocity. And part 4, numerical problems and solutions. So if you like this video and if you find it is useful, share with your friends and please subscribe. Do and learn. Thank you.